response. He's one of the case management medical practitioners, so he coordinates the case management in the loose isolation units and works closely with other case managers in all the other 5 or 6 other isolation centers. So without much ado, Dr. Akase, please, you may start. We're hoping that we'll finish before 10 so that we can all get to go to bed on time. Dr. Shokumbi will maybe organize the question and answers, as we proceed at the end of the talk, and any other announcements will also be handled by her. Thank you very much. Over to you, Dr. Akase. Thank you once again.
Thank you, everyone. Good evening. I apologize for the earlier attempts at our presentation. So, okay, the host has disabled screen sharing. Who is the host? Dr. Shiri, are you the one?
Okay, Dr. Perechi, please, can you permit screen sharing so that he can share his slides, please? Dr. Perechi, are you there?
Yes, ma'am. I'm here, ma'am. I'm doing that now.
Okay.
Perechuku.
He's doing that.
All right, Dr. Akase. Okay, please.
Ma'am?
So you can try sharing now.
Please, can we all kindly mute our microphones, please? If you don't mute your mics, it will pick a lot of surround noise. Dr. Perechuku, your mic is on, please. Thank you very much as you comply. Thank you. Dr. Akase, over to you. Your mic should be on, but it's still muted. Dr. Akase, you can start.
Okay,
please.
okay,
Yes.
good. So thank you once again, everyone, for that. For those of us who are around the morning, I did say that I'm going to divide it into two parts. The first part just essentially deals with the biology of COVID-19 and how it causes disease, and the second part takes us through the process of managing patients from when they come to hospital up till the time when they have a negative test and are discharged from hospital and eventually discharged from care. So, as a way of introduction, coronaviruses are RNA viruses, and viruses are either DNA or RNA. They're never both, unlike human beings or other mammals or other higher animals that have a DNA from where RNA is produced and where from RNA proteins are produced. They eventually carry out activities. For RNA viruses, viruses can be either DNA or RNA, and this has implications especially for certain viruses like COVID-19. One of the implications, I might just say that now, one of the implications is that because COVID-19 is an RNA virus that has RNA-dependent RNA polymerase, the rates of mutation for COVID-19 are not very high. So COVID-19, if you look at from the beginning, the genome sequencing of COVID had remained steady. It does not really differ, unlike DNA or other RNA viruses that are, quite variable and all. So the mortality is linked to age and patients with comorbidities. We're going to see that in a minute. Some of them, like cancer, asthma, and other forms of comorbidities, do present with severe, well, severe disease in that aspect. Now, the biology of COVID-19 is that it's an RNA virus. It's called corona. They're called corona because they look like crowns. You have these spikes around it that makes it look like a crown. And these spikes that are called S proteins, these are like a door. If you have a lock and a key, these spikes are like the keys, and the receptors in the human beings are like the lock. So this key, without the lock on the human being, you know, COVID-19, this virus is not going to be able to attach to human cells and cause infection. And in the human body, you have, and the receptors that the COVID-19 uses is called angiotensin converting enzyme, you know, 2, the type 2. So, and these receptors are bound in the lungs. They're also found in the intestines. They're also found in the kidneys. So, if you look at the symptoms and the complications of COVID-19, most of them center around these organs: the lungs, the kidneys, and the gastrointestinal tract. Now, if you look at this, I don't know how many of us can see this electron microscope diagram. You can see, and I don't know whether you can see my cursor, but you can see that there's an attachment between a SARS-CoV virus here with the spikes. I can see how it is connecting to a human cell or a cell there, and you know, and this process of attachment is the first process of how COVID-19 causes infection among people. Without this process of attachment to the cells, infection cannot occur. So this is very outdated. I must apologize. Okay, I thought I put up a wrong slide. Okay, so at the moment we have like 5.9 million cases worldwide, and in Nigeria, I mean, this is a very, very outdated slide. But what I want to bring out from here is this proportion of active cases versus closed cases. If you look at when the cases are still active, you'll find out that 97% of them present with mild, and that's what you see always, even in the world right now, except of course the past few days was still a slightly different picture. But 97% of when they come are presenting with mild disease, but only 3% are severe. But by the time you're closing the cases, whether they died or they're sample discharged, you find out that 79% of them recovered or discharged, and up to 21% will die. So what happens? How come just 3% of mild cases became 21% of deaths? We'll see this in a short while, and how this can be explained by the understanding of the immunopathology of viruses. As of now, 7 coronaviruses are known to cause disease in humans, 7 of them. 4 of them are beta coronaviruses. Among those 4 that are beta coronaviruses, SARS-CoV-2, which caused the initial SARS outbreak of 2003, 2002 is there. MERS-CoV-2, MRS, that's the one that caused Middle Eastern, is there, as well as these 2 other ones. Of recent, of course, SARS-CoV-2 that causes COVID-19 has also been added to this list. So SARS-CoV-2 or COVID-19 is caused by a beta coronavirus, and that. What are the implications of a beta coronavirus causing infection? It is that almost all beta coronaviruses need a receptor, you know, to bind. For COVID-19, this receptor is not only found in the lungs, but also found in other organs, as I have mentioned subsequently. The alpha coronaviruses primarily are respiratory viruses, and this cause upper respiratory tract infection. So they're going to cause they cause catarrh, and I can, you know, usually when I'm giving this lecture, I like to ask how many people have had coronavirus infection before. And I have fun when I say, people say, no, they have not had coronavirus infections before. And I gladly announce to them that almost everybody has had coronavirus infections before, but then there are alpha viruses, because they're the ones that they are some of the commonest causes of catarrh and, you know, rhinorrhea, you know, in the general population. So that's in terms of the microbiology. So how is it transmitted? It is primarily a droplet-borne infection. Why droplets? I mean, almost all of us know what droplets are. If you are talking around someone that does not have oral continence, when you are talking around them, you feel, saliva falling on your face, touching your face. Those are droplets. Those are droplets. So if you stand too close to people who are talking like that, droplets can fall on their faces, and so therefore that can be a source. So this is how COVID-19 infections occur. And one thing with droplets, that droplets are big. They're usually more than 5 micrometers in size, so they cannot travel so far. So within the travel, at least it's thought that within 1 meter they drop. But to be honest, so droplets drop. That's why they call them droplets, because they drop. But in a few situations, when droplets drop somewhere, either people sneeze in their hands or you touch a table and all that, this can attach to your hands, and when the hands move to the face, this or that. Now, the primary way is droplets, secondarily by contact. What are the implications of this? That if you can put on a mask, and the issue of mask has been thrown beyond that now. I was one of the people that initially doubted the science of masks, but now it's thrown beyond that. The use of masks, okay, to prevent droplets falling on other people's faces. That's one. Two, social distancing, staying away from people by up to 1 meter, at least 2 meters away, or 1.5, 2 meters away, will protect many people against droplet-borne infections. Simple masks, whether it's the one that people are using good cloth materials or surgical masks, will protect these droplets, staying at a distance to protect these droplets, in a significant number of cases. Then when we add that to hand hygiene, it's almost inevitable that this chain of infection can effectively be broken by just these 3 simple measures: face mask, social distancing, and appropriate hand hygiene. Now, the issue of the other transmission routes are possible, like feces, use of toilet and all that. And if people go to the toilet and not wash their hands again, this proves to be very effective. But in all fairness, droplets and hand hygiene are the most relevant routes of transmission within, the general population. The people that work in ICUs and other enclosed environments where they do suctioning, or they're doing ventilation, or they're doing nebulization or giving high flow oxygen, then micro aerosolization can occur, and this can also be transmitted onto other people. Okay. So before I come back to the symptoms, I want to explain something here. I'll come back to the symptoms about the particulars. I think I'm almost through with this biology thing. So if you look at the natural history of COVID-19, what we're seeing is that the phenotype, or the way disease presents, is clearly differentiated into 2 phases, or 2 stages. You have the early stage, and then you have the late stage. In the early stages, what you find is that people come in with fever, headache, myalgia, joint pains and muscle pains, sore throats, and there's a mild cough that is dry without sputum. All the symptoms are as a result of what a virus is doing to the body. And in most cases, and this is why I explained to you why the initial projection of 98% mild to 2% severe can suddenly shift to 21% of severe or death. And this is one way this can be explained, is that in the early parts of the infection, when people still come to hospital, they are just mild, I say, no, I don't have a problem. It's because the virus, they're just still having just the initial viremic phase of illness. Okay, the initial viremic phase of illness. And most people will recover from here. Over 70–80% of people are going to recover, from 80 to 85% are going to recover after this early phase. And so for them, that second phase is recovery. But in about 15 to 20% of people, about, depending on where you're managing, 5 to 20% of people, they enter into the second phase, which is the severe stage. And this usually happens, so this viremic phase goes on in the first 1 week, 7 days or thereabouts. And by the time you enter the second week, most people now enter into the severe stage. And this severe stage is characterized not by what the virus is doing to the body, but by what the body itself is doing in terms of the immune response. And in a small majority of cases, you find that this immune response is inappropriate or disproportionate to the level of virus. Because in most people, by the end of the first week, viral load is already going down and they're on their way to recovery by the end of the second week. But the immune system kicks in and releases cytokines, they call it cytokine release syndrome, and causes all kinds of complications and comorbidities. So this is where acute respiratory distress syndrome can occur. This is where kidney injuries can occur. This is where neurological problems can occur. This is where sudden embolism, thromboembolism can occur. All kinds of complications that affect your major organs can occur in the second phase of illness. And most times, this can occur quite precipitously. Nobody expects it. So I give you an example. We had one of our patients. I'm not going into too much details. Who came in with us. He came with respiratory failure. And we're concerned. He had so much comorbidity. He was hypertensive. He also had, some other infection there. So, and he was doing rather well. After the end of the first week, he was off oxygen. He started ambulating, going about, and we're happy with thinking he was going to go home. And then suddenly he developed pain in the right leg. And the pain in the right was so severe, long story short, he developed sudden onset arterial blockage of the right leg. And eventually developed gangrene, and that leg had to be cut off. He had to be amputated for him to do that. Luckily, the amputation was done on time, so he didn't lose his life. But the point I'm making is that complications can occur in the second week or even the third week. And this is entirely due to the way the immune system is responding. Inflammation and cytokine release can cause all kinds of complications. Vessels become unstable. Blood clots start forming in the lungs, start forming in the large vessels, start forming in small vessels, in the kidneys, in the pancreas, in the intestines, and all kinds of organs. And this accounts for most of the complications of course. So if you go back to this diagram, and I'll go back in a minute before I come back. If you go back to this diagram, you can probably explain why initially that hello? Okay. Yeah, so you probably explain why in the first stage you have 97% and then 30% present with severe disease, while in the later stages, close to 21% of people will eventually develop complications or die. It is because of these complications that occur precipitously. Okay, so having discussed this, I'll go back to why they have the symptoms they have, and we'll probably explain to you so you can see why they have the symptoms. So they are going to have fever because whether it is in the initial viremic phase or the immunopathogenic phase, fever is a characteristic of that. So fever is quite common. They're going to have that. It may be low grade, but they have it. Then they have dry cough. And why is that cough dry? The cough is dry because the receptors for the COVID-19, the SARS-CoV-2, is found mainly in the lower parts of the lungs. So, the mucus producing cells, the goblet cells and all that are found mainly in the trachea and upper respiratory tract. So, this is where the cough is mainly dry. It's only in a few cases that they produce mucus, just 23%. Okay, some come with more fatigue and all that. Yeah, so you can explain most of the symptoms, and you can see that most people are asymptomatic. They have lower respiratory tract infections compared to other coronaviruses that present with catarrh. And adults and children have more severe disease. Adults and elderly have more severe disease compared to the children because the immune response is more robust in adults compared to children. And we all know why they have prominent GI symptoms. This is because of the AC inhibitors that are found in the lungs in plants. Okay, so somebody's singing. Yeah, I was thinking yourself. Okay, so please, if you are not, can you put off your, yeah, good, thank you. Good. So, and to summarize this, the immunology of COVID-19, if you understand this, then you can probably understand everything I've been saying at the beginning as I round up this section, is that one, in majority of people, there is a well-adapted response. This well-adapted response means that by the end of the 7th day or by the end of the first week, the antibody secreting cells and the T cells are going to be produced. And when all this work in tandem, the viral load begins to go down. Okay, the viral load goes down, and recovery, people begin to recover. And so by the end of the second week, you find that most people have recovered anyway. So common experience here have been that for most people, by the second week they'll tell you that the surgery has gone, the lack of smell and lack of taste have all gone, and all of that. And what they are left with is that. But in a few people, 15 to 5 to 15% of the people, they have what they call the maladaptive immune response. And so this is what leads to severe disease. So in other words, most of the people are going to have severe disease in COVID-19. It's not going to be because of what the virus is doing to them. It's because of what their own immune system is doing to them. It's very important for us to understand this and to understand at what point we should expect this. So if somebody has a mild disease in the first week, so here's what we do, and I'm jumping ahead into the process. Once somebody has, even if he has mild symptoms, so long as he has risk factors for severe disease, we don't take that for granted, because you know that the second week is a critical time. So if you have an asthmatic or an elderly person or someone that has, lung problems or heart problems or kidney problems or liver problems or some other severe problem, even if in the first week he's looking fine and all good and everything is going on well, we don't take it for granted. We tell him, you know what, we need to look closely after you, because anything can happen in the second week. And we don't want them to move from the 3% into the 31% statistic, because anything can happen, and it can happen quite precipitously. In other words, so what we're saying is that somebody wakes up in the morning, he's talking with his family on phone. We're saying this quite a number of times on our view word. Somebody in the morning is fine, he's talking, call everybody, they go for water and it's fine. In the evening, suddenly you hear that he cannot breathe anymore, I cannot breathe anymore. And if you don't do something very fast, within a day or two, you hear some other story has come out of that. So this probably just explains why this happens. So in summary, what I hope I was able to, I got feedback that I see when I was talking off prompt, I seem to have spoken more, but I hope I was able to cover. In summary, what I've done in this first part of this discussion is to explain to us the number one, the microbiology of COVID-19, that is an RNA virus that has spikes. Those spikes attach to receptors in human cells called angiotensin converting enzyme receptors. I also explained to us that the transmission of COVID-19 is primarily droplets and secondarily by contact. But but tertiarily, if there's something like that, aerosols can be generated in a few instances, like in ICUs, or when people are laughing loudly, or and all of that, giving oxygen, aerosolization can occur. And if it's time too close, that can happen. And I say that the three most important interventions for COVID-19, it's not PPE primarily, although PPE is important, but it is 1, social distancing, 2, use of a mask, and 3, hand hygiene. Because if you understand the science, you can understand why these 3 interventions have become very, very important for us. I also took us through the natural history of COVID-19, how that in the first week, it is primarily a viremic illness, but that it becomes immunopathogenic in the second week. Immunopathogenic because it is the immune system that is causing the pathology and not the virus itself. And I also explained to us that if you understand all of this that I've said, you can understand why they have the symptoms they have. And when you hear the symptoms, you can probably understand what phase of illness he's in. So if somebody comes in with just a mild cough, dry cough, and just some body weakness, so that he's probably in the viremic phase, especially if he's done that. But by the time somebody is coming with severe illness, that likely this one is already in the second week or something like that, and you should anticipate that you have to be very aggressive when that happens. The other aspect of the other angle to look at this from is this, and this is where probably, so again, I think I need to stress this up because these questions that just come up a lot and I get asked this. So if somebody got exposed to someone with COVID-19  4 weeks ago, and he has symptoms of a cough and all of that, and those symptoms have resolved 2 weeks ago, but he didn't come for COVID testing. So he's coming for COVID testing 4 weeks after his exposure, and you do a COVID test, and that COVID test is positive. At that time, people were literally agitated and they are all, all over the place, and they say, I want to be admitted. At that time, if you follow what I've said, there's really no benefit in admitting such a person, because it was seen that in a large majority of cases, the worst has passed and come and gone. The only real issue you are faced with in such individuals is this, that they may infect other people. But even then, the science is coming out to show that by the end of the second week, and which I think I also can explain by the immunology, by the end of the first week and into the second week, the viral load is going down drastically. So there's a paper in Korea that has shown that after 11 days, people with COVID-19, even if they're still testing positive, are no longer that infectious. And so what we've seen with our patients on admission is this. Somebody comes on admission, you test him on COVID, is positive, he has symptoms, very sick, he's testing positive. The moment symptoms resolve, a few days later, he tests negative and will discharge him home. However, something interesting happens. When he comes back for follow-up, he still tests positive, sometimes for weeks. There are some people who have been unable to discharge from follow-up because they're still testing positive. And now we understand this to be because what the PCR just detects, gene sequences. They don't detect whether the virus is alive or dead. Once that gene sequence is there, PCR is going to tell you positive. So what we found is that for most of those positive results, what you essentially are having are dead virus particles that you're picking on PCR. It doesn't mean the person is infectious. It doesn't mean the person is infected. It doesn't mean it's at risk of severe disease. It only means you're picking dead viruses. And so policy has to reflect this. And I think for Luz, we're trying to work on bringing out a policy that is scientifically sound to acclimate, because we're having people, staff and all that getting exposed and coming to test 3 weeks later and are positive, and you say go and stay home for 2 weeks and so on and so forth. Lots of confusion going on. So, but if you understand the science, or what I've explained in terms of the natural history and the immunology, and the fact that at the end of by the time the immune response, a well-adapted immune response. So how will you know if somebody has a well-adapted immune response? You know this because you tell us you have symptoms, 1 week ago or thereabout, but the symptoms are resolving. Now I'm feeling better. My smell is coming back. My body weakness is reducing, and so on and so forth. You know that his immune response has handled it. But if you have someone who in the first 1 week, and if you go back, I don't know how many of us are in Luz or follow the news, but the first patient that died in Luz, by then Luz, I know he started admitting patients. I don't want to mention his name. He came into the country from somewhere outside the country, and started having symptoms, my symptoms of cough and all of that, sore throat and everything. And he went to one of our testing centers to be tested. At that time, it was fine. They told him, you don't have a problem, go back home. So he went back home, but unfortunately, he was still moving around town with his friends until a week or more later, about the second week or there, right to the third week, his symptoms started worsening. He became more weak. His cough was worsening, but the results was taking so long to come out, so he didn't know what the results was. So it kept worsening until his shortness of breath came in towards the end of the second week. At that time, he became desperate, and the rest, some of us know the story. He had to come to Luz and tell a lie so that he can receive care and all of that. But that's when he died. He died a day or two after, within hours after coming to Luz, when he had already been sick for about 2 weeks or thereabout. This is the typical immunopathogenic, disease we're talking about. And we're quite a number of colleagues, maybe some colleagues or other patients who see them in the first 1 week. They're doing well. They are just managing their symptoms at home, taking medications and all of that. Until second week symptoms just keep worsening, and then what happens is that when you see somebody with that kind of phenotype coming to hospital, I've been sick, I've been fine for the past 1 week. However, in 1 or 2 days ago, symptoms started worsening. We don't wait anymore. We admit them immediately, because it means that they're giving you an indication that they are having a maladapted immune response. Okay, so I hope I've not spoken too much in this area along those lines, but so that's essentially the biology of that. The second part of the so I don't know whether I should pause for questions, but maybe I should go on because of time, so that we don't do that. So this is the first part of that, and the second aspect, I think I'm going to jump into this lecture. Okay. I should go on, is it?
Yes, after we will take questions if we have.
Okay, brilliant, brilliant. My audio is clear, is it?
Very clear.
Okay, good, good.
We're
Thank you.
enjoying you very well.
All right, that's very good. Thank you. Yeah. So when I'm because this is a training for psychosocial team, usually I divide this training into 3 phases. The second phase I do IPC, but I think I'm going to just jump this IPC part. I will look to it in a process phase. So I'm sure we won't be able to do that because of time. I don't want us to keep up for too long. So this just addresses IPC concerns and so on and so forth. Okay. Good. So on to the processes. Now, from when patients come to hospital and they are seen and evaluated up to the time that they discharge and go home, I just want to take us through the process of what we do. So the first thing when people come to hospital is they come to an accident and emergency or a triage area. So for us here in Luz, what happens is that when somebody comes, they first go to an accident and emergency where somebody is triaging them. Triage simply means sorting out. So the first thing in a triage area that needs to do is the first question is, could this person coming to us here have COVID? Could he have COVID? And we use the case definitions by the NCDC. We also use the community case definitions. We also use, experience, because it's important to realize that. So what are the case definitions? Well, most of these terms have become outdated anyway. We have gone past the stage of travel or so on and so forth. But somebody comes in with fever and cough or shortness of breath, which started in the past 14 days. So this is a classical triad of COVID: fever, cough, and shortness of breath in the past 14 days. Okay, you have to suspect or any of these. So somebody coming with any of these symptoms, whether it's a fever alone or a cough alone or shortness of breath alone, you need to ask, could this be COVID? Okay, so if that person has contact with someone with symptoms, then it makes your suspicion stronger. Or if that person is coming from an area that has high incidence of COVID, like Lagos has, then it also makes your suspicion very, very strong indeed. So somebody who comes either of fever or cough or breathing difficulty in an emergency, the first question could be that, could this be COVID? So if you have no reason to think that it is not COVID, then you have to suspect COVID. And the case definitions of that's developed by NCDC recognize that one, there is suspected COVID, which is what I just described. Somebody who has clinical features, who either has been in touch with someone with COVID or comes to the area with high endemicity of COVID, you have to suspect COVID. And so when you don't have any reason else to explain the symptoms, then you have to say this could be COVID. Of course, occasionally you have situations where the person comes with non-specific symptoms, and we've seen this in quite a number of cases where a diabetic patient comes in, or he comes in with hyperglycemia and body weakness. He has no fever, he has no cough or breathing difficulties, but it could be COVID, and that's why experience comes in because of high issues where people that came with diabetes, with hyperglycemia, ended up having COVID, and so that. Or you have somebody who has background heart failure, who has been coughing before and having shortness of breath on exertion. It's not coming with slight worsening or breathlessness. So the question is this heart failure that is worsening, or is this COVID? So it is this kind of, non-specific presentation that experience comes in is that, you know what, I'm suspecting COVID. But this is the first question you need to ask when somebody comes to an accident and emergency ward and say, one, could this be COVID? That's question number one. If you can say yes, or rather, if you cannot say no, so this is what COVID now. This is how this is the psychology of COVID. I don't know whether that's the right word to use, but this is the thinking around the COVID doctor at the ER. If somebody comes to the ward, to the triage area, and they ask you the question, could this be COVID? If you cannot confidently say no, then you have to suspect that this could be COVID and treat as such, because of the various ways in which COVID can present to the accident and emergency. So this is question number one, could this be COVID at the triage area? Question number two at the triage area is that, if this is COVID, how severe is it? This is a very important question, because if somebody comes with a mild disease, and I've explained to us the implications of this, and mild disease simply means he's breathing fine, respiratory rate is less than 30, is saturating fine, SpO2 is more than 90 in adults and more than 92 in children, and it has just a fever and a cough and non-specific symptoms, and he does not have all the risk factors for severe disease. He's not elderly, he does not have asthma, he doesn't have any of those comorbidities, then you say this is COVID. Sorry, this is mild COVID. The implications of this means that sometimes with the space constraints, you can tell them, you know what, I'm suspecting COVID in you, but you are stable. So I'm going to take a swab from you and put some and send it to the lab. You go back home, stay inside, self-isolate, do social distancing until your results come back. So for my disease, they can go back home, you can wait for their results to come back in. But if they come with severe disease, which is that they come with fever, cough as before, but additionally they have problems with breathing, the respiratory rate is fast, the SpO2 is low, and they have other comorbidities and are elderly, they are in shock, they have sepsis, they are confused, they're having seizures or anything like that, then you have to say, this is severe disease. I must look for where I'm going to manage him in the meantime until the results come out. This is so important because if you miss the telltale signs of severe disease, for example, asthmatic comes to you, you're suspecting COVID. He's not having an asthmatic attack, but so he's looking stable to you at that time. This is my COVID, and he goes back home. In the night, an attack will just come up, and that will be that. He will not make it to hospital. He will die before he gets there. Or an elderly person, or a diabetic who is back at home alone and all of that. So you have to recognize the risk factors of severe disease and identify them as such. The challenge comes for us here in Luther and most centers in Lagos is space to keep them when they have just suspected disease and all of that. It's been a big problem, and I'm sure we'll solve it soon. But it's really a big issue because severe. So most of the mortality in COVID for now in Nigeria, and I say the morphology of COVID has shifted slightly in the past few weeks in the country. We're seeing lots of severe diseases come to the ERs, the emergency rooms, and most of them don't have 24 hours to live, so they die in the car, die when you are getting oxygen, die before the results come out, and so on and so forth. So having most of the deaths in COVID are going to occur in that time when people still have what you're still trying to solve. So recognizing severe COVID is quite important. So immediately you suspect COVID. So we're asked, the first question is, could this be COVID? You say yes, you're suspecting COVID. 2, you say, could this be mild or severe disease? You can answer appropriately, mild or severe. Whichever one it is, immediately you think that, then you have to, even while you're doing that, you have to start your infection prevention control measures, which I've mentioned. The 3 most important ones are, face mask, covering your nose and mouth, hand hygiene, and staying social distance. So in an ER, that becomes very, very important. Okay, use of that. So hand counsel patients on cough etiquette. So what we do in the ER is that apart from the doctor or the nurse wearing a face mask, we also see that patients themselves wear face masks. You keep them distance from where you're standing while you are interacting with them, and you limit them. You don't move around all over the place. Go touch the gate. Go and touch this. Go and touch that. It's that way contact. It's other staff are exposed. Through contact. So the healthcare personnel has to apply droplet precautions, which are use of mask and all of that. I'm not getting some of these things until do this and so on and so forth. Bottom line here is, and then you reduce any procedure that's going to generate aerosol. So, and this has to do with anything you need to do, whether you want to suction or you want to cough. Usually, the ideal place to triage COVID patients is an open space where air is blowing and there's good ventilation, and you make sure that you're not where they are talking directly into your face, and so on and so forth. So this kind of measures has to be clear in the eye of the healthcare practitioner as he's seeing COVID patients. So you've seen a COVID patient, you suspect COVID, you have decided whether you're going to keep it, it's going to go home. The next thing you want to do is, since you suspected a COVID, you have to confirm the COVID, whether it is COVID or not. And this is primarily done through sample collection. So there are 2 major samples we take for diagnosis of COVID. 1, we take swabs. 2, we take sputum or aspirate, as the case may be, if the person. So these are the 2 major samples we take for diagnosis of COVID. COVID is not diagnosed from the blood. So we don't take blood samples for diagnosis of COVID. Yes, in a setting of research, or if somebody has, whatever facilities allow, you think there's superimposed infection, you want to do a blood culture, or you want to check his liver function or kidney function or his platelets and all of that, then yes, you can take blood. But for diagnosis of COVID itself, blood is not required. So what are the samples that are taken? Now, the swabs are usually upper respiratory tract, samples. And I'm showing you a picture in a minute. But they're essentially nasopharyngeal swabs and oropharyngeal swabs. These are upper respiratory tract symptoms. You know that the pharynx is one of the high yield areas for COVID, for SARS-CoV-2. So these are the two swabs they take. Then we have the lower respiratory tract samples, which are essentially for us in our outpatients, are essentially sputum. You tell them you need to clear your throat and cough and bring out phlegm and put it in a sputum cup, take it to the lab. Of course, if they're in ICU somewhere then and they're in the trachea tube, or you are doing a bronchoscopy, you can also take aspirates from down in the lung, and this have very high yield indeed. But to all intents and purposes, these three samples, nasopharyngeal swabs, oropharyngeal swab, and sputum, are the three most common and important symptoms we take in the environment for the diagnosis of COVID. Like I said, blood is not used for that. You can take blood for other things like liver function tests and all that, but they are not used for the diagnosis of COVID. So before now, when we started out, even when you confirm, you keep taking the samples every 2 to 3 days until you get 2 consecutive negative results before you say that they are negative, they are going to be discharged home. This has changed for a number of reasons. One, we don't have the resources to keep doing that. Two, both financial resources, human resources, space constraints cannot allow us to keep doing this. So what we do now is that once somebody comes in and you confirm COVID and is going to be on admission, we take sample once in the duration of, so we take sample on day 8 or day 9, or at least once a week. Here in Luz, we're taking it once a week, but that's where they say take sample on day 9. So if they're one negative, patients are discharged home now. We no longer do 2 consecutive negative results. We discharge patients on 1 negative result. However, even if they're still positive on day 9 or once a week, after they have done 14 days in hospital, they are also sent home. And I think the rationale behind discharging people, even if they're positive after 2 weeks, is underlined by what I've explained earlier on. That by the end of the 2nd week, and this is underlined by the fact that their symptoms have resolved for at least 3 days, we here will say for at least 7 days. Because somebody whose symptoms have resolved will know that the person has a well-adapted immune response. It is also likely that what is excreting are dead RNA viruses and not infectious particles. So it makes a lot of sense to discharge them after 2 weeks on admission to go home and no longer wait for 2 negative results and that. So this is a diagram of how we take nasopharyngeal samples is through the nose, and these are not nasal swabs. It's actually not very comfortable, but that swab stick has to go into the pharynx, and then you let it soak for like 2-3 minutes to get in those samples in there, and then you bring it out. This is a sample. This is a picture of an oropharyngeal, swab, where you tell people to do and you go behind the uvula to take samples in the pharynx. Okay, you don't swab the palate, you don't swab the tongue. You go into the nasopharynx and take your sample there. It's also not a very comfortable, procedure, but it has to be done. So, because this is what gives you the best use for patients. So you've taken your samples now. So what do you do in the meantime? And I'm going to carry us through. I've drawn a diagram to explain this process. So don't just stay with me until the end. I'm through in the next few minutes. So after samples are taken, if they are severe disease and you know that they cannot go home, you keep them in a holding area until the diagnosis is confirmed. And one of the things that happen in the holding area is that ideally that holding area should separate patients one from another. You don't want one patient coming from home, which is COVID, another one coming without COVID, and then the 2 of them sharing COVID in the ward, even when they didn't come with that. You don't want that to happen. So you keep them in the holding area until the diagnosis is confirmed. Then once the diagnosis is confirmed, from there they can go to the confirmed ward, or also that is B ward, where they stay there until you discharge them. However, if in the isolation ward a sample test negative, from there you discharge them home, and they go home if you have no reason to test. That sometimes when you feel that no index of suspicion is still very high, you still keep them and test them again, but that doesn't happen very frequently. Okay, and then we'll do that. Now, it's important to realize that the processes of an isolation ward is very important. And I think, we as a psychiatric team need to have this clear. In the average isolation ward, we have two clear demarcations. We have what they call the green area. The green area is where staff come in from home and stay there. They can stay there, change their clothes into scrubs. They can keep their water there, keep their food there, keep their, and all of that. Then when they want to go in and see a patient, whether it's in the holding area or it's the confirmed ward, they need to wear a appropriate PPE to do this. So they change into the PPE in the green area before they step into what they call the red area or the hot zone or the infected zone. So when they go from the green zone into the infected area and they attend to patients there, and usually this happens 3 times a day, routinely, 3 times a day. So patients who need routine care medication and all that, they get seen 3 times a day. However, if we do have bad patients that require close care, then sometimes staff may need to go in more frequently, than usual. But usually it's 3 times a day. So when they finish whatever they're doing in the ward, then they go out through a separate pathway. They don't come back the way they came. They go out through, we call it a unidirectional flow. Movement in an infectious disease ward is unidirectional. You go from the non-infected area, you go into the infected area, and then from the infected area, you go out through another pathway to another area where they would contaminate you using various decontaminating material. Here we use 0.5 chlorine. Whereas there's a process to this, which I may not be able to get to today. There's a process to decontamination. And by the time that is done, then the staff follows another pathway round and goes back to the green area where he can, carry on with his normal activities until some other time. So I was mentioning earlier on about some of the confusion about how patients can present atypically. So with the Lobis algorithm, to give a COVID score here and to look at the weighting in weight to the various parameters that we can find, whether it's cough or catarrh or sore throat or diarrhea and so on and so forth and all of that, and then we give a score. Now, if we find that the symptoms somebody has can be explained by an alternative diagnosis, we subtract 3. This is because, like if somebody comes with a cough or shortness of breath right now into the hospital, everybody will say, it's COVID. However, if you look too closely, you find that some people have come with cough and shortness of breath, may have a lung cancer, some will have laryngeal tumors. I was saying all of these things since we started. Some will have a huge pleural effusion in their lungs, and some other thing like that. Some will have a pulmonary embolism. So if you don't look closely, and in fact, one of the tragedies of COVID outbreak has been some of the deaths that we have recorded because even though they didn't have COVID, but because somebody suspected COVID and they were not denied now, they couldn't access care the way they should have while they were waiting for COVID results. So we try to do this so that people have a chance. If there's an alternative diagnosis, it will bring down the score in such a way that people can go on in and have, their care. So here in Luz, if the score is 0 to 2, they admit into accident and emergency and they receive care. The score of 3 to 5 is people be on the alert. Still admitting to E&E, but monitor him closely, observe all the IPC measures and all of that, and if possible, do a chest CT scan to see whether there's something in that chest that can make you give an idea as to whether it is COVID or not. But if it's higher than 5, then likely you need to call infectious disease because you're dealing with COVID clearly, in this case. So I'm going to jump this so that we don't do that. So now you've taken them through triage. You've taken the samples and you confirm disease. You're keeping them now in the confirmed ward. What do you do for them there? What the science and the evidence has clearly shown is that supportive care is a mainstay of COVID treatment. It's a mainstay. So people that have very good supportive care, adequate rehydration, supplemental oxygen if they need it, empirical antimicrobials for severe disease, some vitamins and all of that, good feeding and all of this are more likely to recover than people that do not have all of this. Whether they get irrespective of whatever antiviral that they have received. So supportive care is key, and I think it's very, very important to stress this going forward, because I know in a bid to go, I get asked this all the time. Which one is better? Should I take chloroquine? Should I take hydroxychloroquine? Or should I take zinc or calcium or or Madagascar concoction? What do I take? The most important thing for COVID care is supportive. And this has nothing to do with that, but it's supportive. So saying these people that have, you support them through the first 48 to 72 hours, they're likely to recover. They're likely to recover, except something else drastic comes up along board. Because once we admit them into the world, then we're keeping a close eye on them to detect complications if they do occur. And if complications do occur, then we have to have a high system to refer them for ICU care or for other, care as the case may be, but it's that supportive care is what they need while the immune system, recovers or winds down from, the maladaptive process that they're going through. So the most important thing, and when we're counseling patients, let's make this clear. Yes, I know hydroxychloroquine or azithromycin and all that have been expounded as being that, but this is important. Whether both for prevention and also for treatment. Because I found that people, so even as staff that work in IDU, we've told them, make sure you drink lots of water, make sure you feed well. And I think in Lucia, we are fortunate we have a management, and Adosha is part of that has made sure that staff in IDU do feed well, do get rehydrated. Water is something that we don't joke with, because it's important for both staff who work there, because that supportive care is also important in prophylaxis, not just the treating patients come with that. So how do we do other considerations? Oxygen is the fuel of COVID-19. People that have COVID-19 require lots of oxygen. So if there is any form of respiratory failure, we need to make sure that they're getting enough oxygen, and that will manage other complications as they come by various that. So what are the specific anti-COVID-19 treatments that are available? None so far has been shown to be superior over another. Of course, there are studies coming out to show that hydroxychloroquine is not so, it has a risk to people and all of that. But I mean, there's so much going on, and we've been going back and forth over all these things for a while. That at the point in time, we came out and said, coronavirus is not effective, don't give it, and so on and so forth. In the US, remdesivir has been approved, and because it shows, unique benefit to patients who are who have COVID. So I think that's the one that for whom there's clear evidence for. Unfortunately, it's not yet widely available. It is strictly under the control of the US government, and they decide where it goes. I'm not so sure. In fact, it's not gotten full approval yet. So talk of even giving generic brands does not even arise yet. They need to do that. So remdesivir is not available in Nigeria. It's not available to our patients at the moment, except maybe when the trial comes in. By the moment, this is where we are. So in Luz and in all of Lagos, we give lopinavir, ritonavir. It's a HIV medication, anti-HIV medication, and there's something.
Dr. Akase.
Yes.
Dr. Akase. Okay, so I don't know how much more time we have, but I think we should be mindful of. There's already 10 now, so
okay.
Yes. So I very useful information. I'm just thinking of the time, so we want to manage maybe another 5 minutes. Would that work?
No, I'm almost done. It's fine. I think the next slide is the last slide.
Oh,
so
okay,
pregnancy.
People may have a few questions.
So
That's right.
Yes. Okay. Good. So I think I'm almost done. So, so pregnancy, we've had a good experience with pregnant women here. And I think what this has shown is the benefit of having a multidisciplinary team working with COVID patients, because some are going to require more than what the infectious disease people can give. They're going to require dialysis. They're going to require, the endocrinologists and so on and so forth. So a multidisciplinary committee is quite important working with. So in summary, the process of COVID care starts from triage. This is what we do, so triage, and then to sample collection. And when results come out, so I think this is one sample. This is not directly on the purview, but I think this is where statistical people get them. So once samples are taken and results come out, the positive results are communicated to the statistical team, who communicate to the patients, the results, especially positive results to the patients, and also let us know, and then we now admit the patient into the ward and treat them, until or monitor them until they eventually discharge from the hospital. Some may still need to keep follow up on outpatients, but eventually we do discharge them completely. Here from home. So I think that was my last slide. Thank you all very much for listening. So what you do,
All right.
Yes,
Thank you very much. Thank you very much, Dr. Akase, for that very comprehensive and stimulating presentation. I believe we all enjoyed the presentation. Well, I think to make the presentation complete, maybe we should allow for 1 or 2 questions. And there are some questions also on the chat. If you have any question, please signify by raising up your hand. And then later we'll take the questions on the chat. If you have any question, are we tired? I'm not sure I'm seeing any hand. Okay, no hand up. So let me read the ones on the chat. Dr. Akase, are you there?
Good evening, ma. There are 2 hands up, ma.
Okay, all right. So are you one of them?
No, ma.
Okay, so unmute. If your hand is up, please, you can unmute and ask your question.
Good evening, ma. Good evening, sir.
Good evening.
Good evening.
Okay.
Tiwatayo. Okay.
Yes, I'm Dr. Tiwatayo Lashibikon.
All right.
So,
good evening, Dr. Lashibikon.
Okay. But my questions, I think I might have 2 questions. I know that I can't remember the word you used for it now, like a checklist that is used in LUTH. I noticed that anosmia was not one of the symptoms there. And I have a number of my friends who, discovered that was, some of them, that was even the only symptom they had. And for some of them, even after, the fever and all that cough had gone, it was anosmia that was still present for days or maybe 2 weeks thereabout. So I don't know if, you had considered also adding it to the checklist. I know it's not possible to add all the symptoms, but I don't know, maybe it was based on literature search or based on, things in our own environment in particular. Then my second question is also about the checklist. During the lecture, you explained that people who have some underlying conditions like asthma and co may actually have more severe diseases than people who don't. And at the same time, the last line of the checklist, I think it was a score of -3 was given to if anybody has a condition that might mimic COVID symptoms. So I'm just thinking that if someone has COVID and, for example, has maybe asthma or lung disease, he may actually have -3 because of some of the symptoms. But may also be maybe sending somebody back who may later develop severe COVID symptoms. So I don't know if we've
thank you very much. That's a great question. So I think the first part of the question about the anosmia.
Would you like to take the second and so that you answer the 2 questions, sir?
Okay, from him.
So
Okay.
yes. Okay, so the second person, please unmute and ask your question.
Okay, good evening, ma'am.
Yeah, good evening.
My name is Dr. Aushri. Thank you very much, Dr. Akase, for the presentation. My question is, when you were explaining the pathology, you said that robust immunological response is responsible for the severe symptoms. Now, then you also said that immunocompromised people are also at risk of developing severe COVID symptoms. So I'm just wondering if, because some people that have that are immunocompromised, they don't have enough immune response. So how then would they develop a robust immune response? I don't know if my question is.
Yeah.
But that's my question. Then the second one is that, is it possible, because we've been hearing of cases of reactivation, that is it possible that some of the dead coronavirus becomes they come alive, or how then do we have reactivation in somebody that initially tested negative? Thank you, sir.
Okay, thank you.
All right, sir. You can go on.
Okay,
You
thank you
can
very
answer
much.
the 2 questions, yes.
Okay, good. So, Dr. Lashebikon, he had 2 questions. The first one was about anosmia and loss of teeth. Yeah, so we're also seeing question road that we're going to add that to the list. So that list, that checklist is due for revision. I revised it before. So initially we didn't put the -3 there. So that's interesting. We didn't put the -3 there, and so we're capturing all kinds of patients. All those who had COVID, and most of them didn't have COVID. So the -3 there in that checklist, really, if you look at it, the aim of that -3 is to downgrade their score so that they can have, an acute, imaging or something done. If you look at the score, what we find out that if the score is more than 5, they will not do CT for them, they will not do radiology for them. But if you consider that they have an alternative diagnosis, and that's where the real confusion comes in, because there's real confusion. That's 1. 2, they don't have 2 to 3 days to wait for COVID testing. You need to have an alternative, testing like a chest CT or chest X-ray to quickly give an idea of what you're dealing with. So that's the major aim of that, that -3 to account for alternative diagnosis. And in truth, what we found is that even though yes, people with underlying conditions do have risk for to have more severe disease, but we found out that if by the time they come with severe disease, if you put on that score is going to be quite high indeed. So even when you remove the 3 there, it doesn't really change. It doesn't bring it less than 5 or something like that. So but the aim of that -3 is so that they can be able to assess CT scan if they need to, so that they can quickly make a decision without waiting for 3 days for that to happen. Okay. So the second person spoke about the immune response, being that I said a robust immune response causes immunopathology. Yet immunodeficient people may be at risk of severe COVID-19. Now, immunodeficiency or a dysfunctional immune system, I don't know what I specifically said immunodeficiency in the setting of that. What we have observed is that people with the typical immunodeficiency conditions, like HIV, like sickle cell, like people on steroids and all of that, we're not seeing them come down particularly pregnancy. We're not seeing them come down with particularly severe COVID as an independent risk factor in itself. Interestingly, when we have had sick class come on admission, they have done rather well, and in fact, they've not had the severe problems, they've gone home. We've had pregnant women, of course, got a number. They did very, very well and went home. We had HIV patients come in, and they did rather well and went home. So I think it also plays into what we're discussing, that maybe a deficient immune system, the typical immunodeficiency syndromes that we know, may not necessarily predispose them to severe disease. However, conditions like, and most of them, this is the kind of deficiency in the immune response. So when you say immune deficiency, a deficiency in the immune response, it may be a deficiency in appropriateness. So, and I did mention this, that a maladaptive immune response, not necessarily immunodeficient response, but a maladaptive immune response doesn't know where to start and where to stop. And especially when you have organs that are unable to handle the physiological demands of the immune response. So you have a lung that cannot handle the stress of immune response, a heart that cannot handle that. This is where we've seen most of the severe disease, not necessarily your typical deficiencies with the immune cells per se. So probably that's what explains that in terms of some of the things.
Okay. Thank you very much, Dr. Akase. All right, does anybody have another question before I read out the ones on the chat? Okay, let me quickly read them out. I'm sure we'll be done in another 5 minutes. Okay, the first one, for people with chronic medical condition in the community who might not make it to the isolation center in the first week of mild symptoms, what is your advice for their management? Did you get the question, sir?
No, I didn't.
Okay, for the people that have chronic medical conditions in the community who might not make it to the isolation center in the first week of their mild symptoms, what is your advice for their management? Then the second question, no.
Go ahead.
Okay, the second one is how long it takes for the results to be confirmed after samples are taken. And the third one, I hope we are not, taking the, are you with me?
Yes,
A patient who is positive 2 weeks ago, but symptoms resolve after taking anti-malaria. When patients redo the test, it's still positive, but no complaint. For such patients, what next? So that's 3 questions, okay? So you can answer. I think I have 2 more questions. Okay, take the 3, but just to make it snappy.
Okay, good. So the first one was about okay, let me start from the third one. I'm sure I remember that. Okay, so the third one is about some people spend 2 weeks more in the community and it's coming out. So that's where the policy needs to come out from that. At the moment, we don't have that kind of policy in the country. But what I've been trying to do and what we start doing is somebody who has symptoms recovered 2 weeks ago, test comes back negative. So again, that's where testing, the criteria for testing needs to be put into place. Somebody who would call for symptoms 2 weeks ago, personally, I won't test them. I won't test them. So when they do get tested now and give a positive result, it causes confusion. Again, if I'm the one, I won't admit them. I will tell them, go back home, it's likely your symptoms are resolving. If there's any issue, you can get in touch as soon as. So this is where the home care thing is not coming in. Someone needs to be in touch with them to guide them through that process. Now, for somebody who was in a community, who has chronic mobility and could not come to hospital, again, that's what home care is supposed to take care of. Don't mean somebody is tested, has symptoms in the first week. First, you should go quickly to get tested. But 2, even if you got tested and the result was negative, that's where at every LCD has a medical officer of health. They should be able to get in touch and say, okay, we're following this person up. Should he be at home? Should we go to a facility? So admissions to a facility even needs to be coordinated now. Before now, people just walk into hospital and get admitted. I want to be in hospital. But now with space constraint, I think we need to strategize and say those risk factors with severe disease are the ones that should be going to hospital, not those with mild symptoms or no symptoms at all. I've answered all the questions.
Okay, let me just take the next question. Taking the nasopharyngeal swab could stimulate sneezing. What is the rate of protection with the PPE while taking samples? And then the last question, are there patients with no symptoms at all?
Okay, so for the last question, that's the last question.
Yeah.
So the last question, there are lots of patients with no symptoms at all. And in fact, this is one of the things, one of the amplifiers of community transmission that without symptoms at all. So when you are taking samples, yes, patients may sneeze and want to be careful, and that is why taking samples, you have to have a face shield, a face cover, you have to have an N95 mask, and also at least the minimum of a surgical gown. So for taking vaccines, you have to protect the face completely. N95 mask and a face shield or eye goggles to cover the eyes. where you are doing that, and then of course double gloves and so on and so forth. And we always have things to decontaminate appropriately. Positioning is also key. So when we're taking samples, we stand by the side. You don't go stand in front of in somebody's face and take samples. Like you said, you sneeze into your face or cough into your face. So you stay by the side and tell them to face that way while you take samples from an angle. I mean, it even gives you a better position anyway to do that. So even if it's sneezing, you can quickly duck out of the way and then it does its business and you do that.
Thank you very much, Dr. Akase. I would want to ask, can we share your slides? I mean, a lot of people have been asking, but let me just ask you again. I know you will definitely do, but
Dr. Shokumi, I have a question, please.
okay, sir. Who am I not to allow you?
Sorry, but I have to come in late to ask this question. It's a problem we've been encountering. Dr. Akase, thank you very much for that beautiful presentation once more. We always like listening to you.
Yeah, yes, thank you.
I just have just one question. We have so many patients who have stayed up to 24 days in your center, and they have not been discharged. And with this new discharge protocol, what could be the possible problem? Why they're still staying that long?
Okay, thank you very much, Dr. Ome. So there are two major reasons why some patients are staying that long. One is that we have a lot of loose staff, especially what's the word now? Interns and house officers who are infected on that ward. And most of them, they share accommodation. So we discussed and said for an intern or a house officer, somebody who is sharing accommodation and comes in because of positive results, we will not discharge until it turns negative. It only makes sense. So because otherwise, I mean, most of them don't have symptoms anyway. The main reason that detail was so that they won't share to other people. So it doesn't make sense to do that. Secondly, the second reason why we stay that long is when we are discharging people, we ask them 3 questions. There are 3 criteria that we use to discharge them. One is that they must be symptom free. So if you have somebody that has symptoms, we don't discharge him until those symptoms are resolved. That's one. 2, the person must be able to safely self-isolate at home. It's not sensible to discharge someone who is still positive to go into the community and share a room with all kinds of people and then disseminate, that to them. Okay. And then 3, even if it's not up to 14 days, but he has spent that, we can still discharge him home. What we found with most of our patients in the world is that 1, those that have stayed this long that have not yet gone home, the commonest complaint, the commonest reason why they are not going is because, well, yes, if they are loose staff, then that's why, and they're still RMO, then that's why. So some of them tell us that, I'm protecting my family. I cannot safely self-isolate at all. So in most cases, if they are not to do staff, if the patient is loose staff and is still on admission, it is him that says or her to say doesn't want to go. And when they do, they say that we obviously cannot force them to go out against the will.
All right. Okay, Dr. Ome, are you fine?
Yes, I'm fine. Thank you very much.
All right. Okay, Dr. Akase, you have not answered. I hope we can share your slides.
No, I have. I said, yeah, you can. I'll share it. I'll send it to Dr. Oshodi and she can share it to the rest of you.
All right. And then you have not answered.
Hello?
How long it takes for the results to be out? It's a question from one of the.
Okay, so so the issue of the results coming out, so it depends on which facility. So for Luth, I can speak for Luth. I know for mainland, I don't know what the issues are, but the results take longer there to come out. Here in Luth, depends on what time of the day those samples are taken. If, for example, we take a sample before 9 a.m. in the morning, we'll take a sample, let's say 8 a.m. in the morning. By evening of that same day, we'll have that result with us. However, if you take a sample, say 2 p.m. or 3 p.m. or 1 p.m., and it gets to the lab, they will keep them and run them the next day. So by the time they finish running them, and when the results are available, except somebody is interested in it, otherwise, we have to wait for them to load it onto the platform, which takes sometimes the whole night and all of that. So if you take a sample today by 2 p.m., it will not be run today, it will be run tomorrow. Then before the sample get uploaded onto the server, it will take another, a few hours or so. So in for all intents and purposes, 48 hours, the result is online from sample being taken. However, if you're somebody particular, you really do need to know what the result is. You can follow it up and then get to know, maybe find out another. But it's not sustainable for many people. So the would say it's 48 to 72 hours in case something else goes something with this. Other facilities, I know it takes a little longer, but and for loose, that's about 48 to 72 hours to tell them.
Okay, thank you, sir. Dr. Umen, Dr. Shodi, do you want to answer? Naima takes like how many days? Okay, I know that Naima takes about, okay.
Go on, please. Go on, Dr. Shukumbi, because I was going to say I'm not too sure.
Naima takes about 4 or 5 days. Naima has a procedure, and you register when you to come for your test. And I think within 3-5 days, they do get their results. In Yaba, I try to find out why it takes 2 weeks before results comes out. And they tell me that they have lots and lots of samples. Samples from all local governments comes down from everywhere, comes to Yaba, that by the time you do one, the next one takes another, before you get to, anyway, the span is like almost 2 weeks. And that's why it takes about 2 weeks. I'm going to get there this week by the grace of God to actually see what is happening. But that is the reason. It's because of the quantity of samples.
Volume of it that they're doing.
Yeah, the volume, yeah. All right, thank you. Well, I think it's been a very, very impactful day. But before we call it a day, I just want to remind us that we should please keep our Saturday and Sunday evening open, please. The message was sent to the platform this evening. Let's try and check our platform, especially the new men. We will be working next week by the grace of God, and therefore the need to have some basic essential skills to equip us for next week. The details will be communicated to us when we discuss and finalize with our speakers. One of our speakers, in fact, 2 of them are on the platform, and I know they would not say no. So we will definitely communicate the details to us. And again, like I said on the platform, if you have not forwarded your account details, please do. And by the grace of God, we hope that we'll get our funds before the end of next week. All right, on that note, I want to say a very big thank you to Dr. Akase again for that very beautiful presentation. Can we unmute and say a big thank you together? Dr. Akase, I hope
thank you,
Thank you, Dr. Akase. Thank you very much. We enjoyed the presentation.
God bless you.
God bless you.
Thank you.
Okay,
Thank you for the job well done.
Everyone, I appreciate it.
Wonderful job.
Thank you very much.
All right, we'll try as much as possible to keep to 1 hour, latest 1 hour, 15 minutes subsequently, especially this weekend. Dr. Oshodi, thank you very much for organizing this for us. Dr. Ume, thank you very much. And thank you in anticipation of this weekend presentation. I wish you all a very peaceful and a restful. Tomorrow by the grace of God. Dr. Ume, I'm going to call you right away. Dr. Ume, I'm calling you now. Yes, I'm going to call you, sir. I need to.
Yes, ma'am.
All right.
Okay.